Okay, so we're going to talk about vectors and applications of incline. So let's talk about finding the force required to keep a 2,700-pound car parked on a hill that makes a 13-degree angle with the horizontal. Okay, so you can't do this problem unless you have some knowledge of physics. So if you've never had physics before, don't worry, I'll show you how these are set up. They're all really set up the same way, but yeah, if you don't know anything about this, then it would be impossible. So there's the situation. And I highly recommend, by the way, that you draw this so that you get the full kind of like experience. So we're going to talk about all of the hidden forces that are in this situation, because there's actually a lot. Okay, so first of all, let's label these points. So we'll just call this A. Okay, so from here to here, so this force required to push the ramp, or the car up the ramp, this is going to be this force. We'll label it BC. And then, okay, so gravity, like when you take physics, this is like physics 101. So just like remember this in physics. So gravity is always acting, and when we're on Earth, right, gravity is always pulling everything back down to the Earth. So the reason why this car is not flying off into the air, into space, is because gravity is literally pulling it down. And when gravity does that, it makes a right angle with this horizontal. Okay, so this force here, BD, so this makes a right angle with the incline. And you can think of this now as this is the force of the car pushing down on the ramp. So we have gravity keeping the car on Earth, and then at the same time we have this force of the car pushing down against the ramp. And this one makes a right angle with the incline. So you want to keep all these right angles straight, because this will really help make sense of what we're going to do next. Okay, now the last thing is, so we've got this gravity vector, and then we've got this BD, so this weight of the car pushing, and then so from here to here, so this is going to be ED. So we can create this other vector. So this vector here is actually, it runs parallel, and it's like the same vector. They're equal to BC. So this force that we're looking to just figure out, like, what does it take to keep this car parked on the hill, this is really what we want right here. We can find that with this analogous vector. So it's a lot. That's why you want to take a second to really draw everything. And when we have this creates a right triangle. So this is a right triangle. We get a right triangle here. This makes a right angle. So you just want to pay attention to this, okay? All right, a couple more things. So gravity is actually, so this gravity vector, this is the sum of BD and negative ED, okay? And remember, so these two they're actually running parallel. They're in the same direction. I might not have it perfectly to scale, but that's why I drew the little pink line. All right, now, since these two vectors are equal, they're going to have the same magnitude. So you get the strategy with this, right? So this strategy here then is, if we find this, then we've also found this. So we're talking about the force required. That's the same thing as saying just what is the magnitude of the vector. That's like in general. So we're going to look for this ED. Okay, so a couple other things now with this situation. So this incline here is 13 degrees. And then with how this gets formed, with like how this force is pushing down and everything else, this is the same angle. These two angles are the same. Okay. And all right. So this gravity, this is going to be equivalent to the weight of the car. So this vector, the magnitude of this vector is 2,700 pounds. Okay, so now we have this BDE, which is this right triangle. And remember, what I said was I wanted to find the magnitude of this ED. And actually now I've got everything that I need, right? So I know that this is 13 degrees. This is a right triangle. So when I have a right triangle, it's like bada bing, bada boom. That's the easiest situation you can have to solve for, right? So this is a right triangle. I can just use my right triangle trig, no problem. Sine of 13 degrees, opposite over hypotenuse, which I know. And so actually this actually comes together quite nicely once you know what the picture is. So the magnitude of ED is 607.37 pounds, and so that is actually then the force required. Okay, so that was a lot that I just told you. So let's talk about another situation. A force of 18 pounds is required to hold a 74-pound crate on a ramp. So what angle does the ramp make with the horizontal? All right, so this is actually a pretty similar problem to what we were just talking about. So I think this is a really good chance to, hopefully you like took some really good notes, because if like you're not going to get this if you just sit here and watch this. The best way to understand this, you know me, math's not a spectator sport, you've got to sketch this. You've got to sketch this, or these problems are just going to totally evade you. So I think you should pause. I think you should try to sketch it. Even if you get the sketch wrong, you'll learn more. Trust me. And hit play when you're ready. Okay, so we got a crate on a ramp. Boom. I don't know what angle it makes, the ramp makes with the horizontal, but this is the same situation from before. So the ramp, or the crate on the ramp, that force makes this right angle, and then gravity is coming down. So the crate is 74 pounds, so that is the magnitude of this part. And then we're told that the force required to hold this crate is 18 pounds. So in this case, that would be this measure here, which would be equal to, remember there's like another little vector that's like the force required to like push this up, which is really the force that's holding the crate. So this vector here is equivalent to the force required to hold the crate. Okay, so anyways, so now what I want to find here is I have a right triangle here. This makes a right triangle. So I want to find this angle theta. If I find this angle, then I've also found this angle. All right, I think you have enough information to do this. This is a right triangle. I think you can finish this. So if you haven't finished it, I'd hit pause and finish it. So what I have here is sine of theta. It's opposite over hypotenuse, 18 over 74. So then I just take the inverse of that and I get theta will be equal to 14.078 degrees. And so that would be that angle. Okay, so that's it for this video. Oops. So if you found it helpful, consider liking, commenting, whatever. Otherwise, I will see you guys in another video.